morning students. Let us say same chapter, chapter number 12, and it is video number 42. Okay, in this video we will see about electron orbits. Okay, as we have seen earlier, Rutherford has invented nucleus. What is nucleus? The center part of an atom in which entire mass is concentrated as well as it is positively charged. Right? That center part of an atom is known as nucleus. Then there was a empty space, and after that empty space there was an orbit in which electrons are revolving around the nucleus. Got it? This is, we have already seen in chemistry also. Okay, around the nucleus electrons are orbiting in the orbit. Clear? Okay, see. When the electrons are orbiting around the nucleus in that orbit, but in this topic there is one specific word. What is that word? That word is nothing but stable orbit. What do you mean by stable orbit? Okay, the definition is not there in our textbook, but what is the stable orbit? The stable orbit are the orbits in which electrons are revolving around the nucleus without emitting energy. Once again, what is the stable orbit? The stable orbit in which electrons are revolving around the nucleus without emitting energy. Such orbit is known as stable orbit. I will repeat this definition of stable orbit after two topics, after two videos. The same thing will be there. At that time you will see. Okay? Now, as we know, electrons are revolving around the nucleus in a stable orbit. So, let us see. Figure is not there once again, but we are looking for that figure for our simplicity. Suppose this is nucleus of which atom? Hydrogen atom. This nucleus having charge, how much? Ze. Okay? If it is a hydrogen atom, Z is its atomic number and it is taken as 1. Simple. Consider a hydrogen atom having charge Ze, where Z is the atomic number of hydrogen and it is equal to 1, and electron is revolving around the nucleus having charge E. So this is the electron which is orbiting in a stable orbit around the nucleus having radius R and with constant velocity V. Is it okay? Once again, how to write, what to write. As shown in figure, consider hydrogen atom. The nucleus of an hydrogen atom consists of charge Ze. Electron is revolving in a stable orbit having velocity V and radius R. So, there is a force between nucleus and charge that is the Coulombian repulsive force, or you can say that it is electrical force. So that electrical force Fe, which is same as centripetal force. Why centripetal force? Because electrons are revolving around the nucleus in a circular path with a constant velocity. So this is the definition of that uniform circular motion. In 11th standard already we have seen this definition. Once again, what is uniform circular motion? When an object is moving in a circular path with constant velocity v, such motion of a body is known as uniform circular motion. And when there is a uniform circular motion, centripetal force acts, Fc. Centripetal force acts on that moving body. Here moving body is nothing but E, electron. And that centripetal force is provided by nucleus. Means nucleus will apply centripetal force to the electron. Clear? These two forces are equal. We know that centripetal force is nothing but mv square by r. What is m? M is nothing but mass of electron. What is v? Velocity of electron. And r is the radius. Is equal to Coulombian repulsive force, that we know k, value of k 1 upon 4 pi epsilon 0 multiplied by q1 q2. q1 q2 are the charges. Here q1 you have to take Ze, but you have to put Z is equal to 1, so it will be E. q2 again E, so it is E square by R square. Right? This is the main equation of calculating the electron orbits. Okay? Electron orbits, what to calculate? You have to find the radius of electron orbit. So from this we are going to find its radius. How to find? It is very easy. R will cancel out. So we will have only this equation, mv square is equal to 1 upon 4 pi epsilon 0 multiplied by E square upon, here r will cancel out, so only 1 r will remain. Okay, now make a subject r. What is r? R is the radius of electron orbit, is equal to, take r on this side, mv square on this side. So you will get E square upon 4 pi epsilon 0 multiplied by m v square. So this is the equation of radius of electron orbit, and it also shows the relationship between nuclear radius, that means the radius of electron, and v, velocity of electron moving around the nucleus. Clear? See, very simple thing is there. Okay? From this we also have to find equation of velocity. Why? Because after this topic, I think so, in illustration number 12.3, one equation is used. That equation is used to find the velocity. So you have to take the same equation, from that make a subject v. So if you are taking the equation of velocity, then take m on this side, so you will get v square is equal to the entire term as it is, take m on this side, so it is E square upon 4 pi epsilon 0 as it is, take m on this side, that is m r. You have to find the equation of velocity. So here take square root. When you are taking square root, so v is equal to e square and its square root. So it is e upon, in denominator, entire term will come in that square root. So it is 4 pi epsilon 0 m r. Clear? So this is the equation of velocity that we will use in illustration number 12.3. Okay? So simple things are there. To find the radius of electron orbit. What is electron orbit? The circular path in which electrons are revolving around the nucleus, and that circular path is known as stable orbit. What is stable orbit? I will not repeat this definition. Okay? That repetition you will get after 2 lectures, after 2 videos. Okay? Then centripetal force acting on electron due to nucleus is same as Coulombian repulsive force between that electron and nucleus. So you will get the radius, make the subject v, you will get the equation of velocity. Have a look. After few seconds, we will find the equation of kinetic energy, potential energy and total energy of electron. Have a look. Okay? Now, let us see equation of kinetic energy. So we are taking this equation. Why? Because we know that equation of kinetic energy from the ninth standard. So kinetic energy is nothing but K is equal to 1/2 m v square. V square is here. Put the value of v square. So you will get 1/2 m multiplied by v square, that is e square upon 4 pi epsilon 0 m r. So m will cancel out. So you will get the equation of kinetic energy. K is equal to 1/2. Oh, 2 4s are 8. So it is 8 pi epsilon 0 r and square as it is. Okay, so this is the equation of kinetic energy. And if you want to find the equation of potential energy, then in a simple way you will get U is equal to minus e square upon 8 here 4 pi epsilon 0 multiplied by r. So this is the equation of kinetic energy as well as equation of potential energy. Okay, here negative sign indicates this energy is along which direction? R, that is negative R direction. Clear? So this thing you have to remember, that the potential energy indicates negative sign, and that negative sign gives us the energy is along negative, means decreasing distance. Potential energy is in the direction of decreasing distance. Is it? Now we know that very well. Kinetic energy plus potential energy is nothing but total energy of electron. So let us see total energy, and total energy is nothing but E is equal to sum of kinetic energy plus potential energy. Both equations are here. See, that is kinetic energy K is equal to E square upon 8 pi epsilon 0, 8 pi epsilon 0 R plus minus E square upon 4 pi epsilon 0 multiplied by R. What will come out as a common? So you will get E square upon 4 pi epsilon 0 multiplied by R. So here 4 common, what will remain? 1 half plus minus 1. So 1 half minus 1 minus 1 half. So you will get E is equal to minus E square upon 4 pi epsilon 0 multiplied by R multiplied by 2. So it is 8 pi epsilon 0 R. So this is equation of total energy of electron. Again, here there is a negative sign, and this negative sign indicates electron reside. Reside means electrons will remain in the orbit. Reside in stable orbit. Suppose total energy of electron is plus, then what will happen? Think of that. It is similar questions that we have seen in chapter gravitation of 11th standard. Escape velocity of satellite. Escape velocity of satellite, potential energy was negative. Got it? And because of that, it will remain on the earth. But if the potential energy is positive, then what will happen? The satellite go out from the gravitational field of the earth, and it cannot bring back to the earth. Same thing is here. If negative sign is there, it indicates energy is negative. If energy is negative, means electron reside in the stable orbit, means electrons are orbiting around the nucleus. But if there is a positive energy, that electron go out from the orbit and it cannot return back to that orbit. So this is the reason, and one question I have asked in that homework also. Okay, so you have to think about that. Okay, simple equations are there, mathematical steps are there. It is a combination of nuclear physics with classical physics. Classical means plus, minus, take common, means there are some mathematical steps which coincide, which you have to bring together with nuclear physics. Okay? થોડું વધારે થઈ ગયું છે, right? પણ આગળ when we will go further, you will get the idea about what is classical physics, what is nuclear physics. Okay? That we will see afterwards. Have a look for a few seconds and enjoy the video. Have a good day.